Hi everyone, how are you guys? Hope everyone doing fine. In this opportunity, we will continue to exercise writing mathematical model on Google Colab and solve it using Gurobi solver. Today, we will explore another model. We call it lot sizing model. Lot sizing refers to the process of determining the optimal quantity of items to order in each period, considering factors such as demand, fixed costs, holding costs to minimize the total expected cost. In this model, we have available demand D over relevant time horizon T. There's a setup cost A and holding cost small h, and the problem is how to minimize the sum of total costs, which consists of setup cost and inventory cost. In summary, here in this model, we have 6 parameters, 3 variables with minimization objective function to minimize setup costs and inventory holding costs. We also have 4 constraints and non-negativity constraints. Without further ado, let's start this video. As usual, we need to install Gurobi by downloading Gurobi by typing pip install Gurobi Pi and then import Gurobi to Google Colab. From Gurobi Pi, import. Let's run it. Wait until it finishes. Now we are ready. Then we prepare the parameters and the data. First, suppose we have 12 periods and then the demand is for 12 periods. Suppose we have 100, 100, 0, 200, 100, 300, 400, 0, 100, 100. In total, we have 12 periods demand. And then we also will write the capacity C. For example, we have 800 capacity, and then setup cost is 500, inventory holding cost is 2, and then the sufficient large number. Let's say we have 999. After writing the parameters and its data, we continue writing the variables. As you can see, we have 3 variables. Before defining variable, we create the model itself by writing m equal model and then lot sizing. Then we write variable q. So we will create an array, and then for the time periods in range 12, we create q and then index small t equal m at var and then v type to describe the type of variable. Right now, the type of variable is continuous. Then we continue writing variable inventory, which has the same characteristic, and I will copy it and change it with I. The last variable is variable z, which is a binary variable. So in order to write down, we have the same, and then switch C with B, which stands for binary. Then we finish writing the variables. Then we continue writing the objective function. As you can see over here, we are minimizing setup costs and then inventory holding costs. We straightforward use m set objective, okay, and then because we have a sigma over here, so I will use quick sum comment, and then start with a multiplied by c with index small t plus small h multiplied by I small t, h multiplied by I and then t over here. Don't forget to write down for t in range t like this. Since we are minimizing the objective function, we should put m model sense equal to 1. If you want to maximizing, we can change 1 into 0. And then we continue to writing the constraint. The first constraint is I0 equal to 0. So I just straightforward m at constraint and then I0 equal to 0. Okay, for the next one, the inventory IT equal to QT minus D small t plus IT minus 1. And then we see that we have notation for all here, T in big T. So we will use for T in range T. And then we add M at constraint, something like this. And then IT equal production QT minus the demand T, and then plus inventory in the previous period T minus 1. Since we are starting not with 0 because we have T minus 1, so we will should put 1 comma T. So we are not starting from 0, but we start from 1. Okay, the next is constraint is this one, big M multiplied by ZT greater than QT. The same we have notation for all T element capital T. So we should put for T in range T, we put M at constraint and then M multiplied by ZT is greater than equal QT, something like this. Next, the next constraint is QT less than equal the capacity. The same we have notation for all over here. I will just copy it for the next constraint and then change the constraint QT is less equal than the capacity of production. And then the next is non-negativity constraint and then the definition of variable z, which is a binary. In default, Gurobi will set all our variables non-negative, so we don't need to write the last two constraints in the model. Then to optimize, we just type M optimize. Okay, let's see if we can run this one. Is there any error? A in advar should be small.
Okay, the next, this one also is small.
Okay, and then we have the result. If you want to show the result, you can print here M objective file to print objective value, and then print, if you want to know the computation, M runtime in second. Let's see. Okay, we have the objective function and then the computation time. If you want to also show variable Q, the result for the production per time period, we just can type for the T in range big T and then print, for example, production period and then T equal, then we have a variable qt, and don't forget to put dot x because this is the result for variable. Let's run it and then we have the result for 12 period. If you want to also, for example, want to know the inventory for each period, you just put here and then change inventory for the text and then change the variable into I. Then we have the result. We have inventory in period 4 and 9. That's it. This is the simple lot sizing model. Thank you for watching this video. Hope it can help you. If you feel this video helpful, don't forget to like, make a comment, and subscribe. See you again in the next video. Goodbye.